Finding the distance from a point to a line is in Geometry and Algebra 1, and it is one of the longer problems. It has several steps to it, but what we want to do is find the distance from 1, 0, that's this point right here, to the line y equals negative x plus 3. All right, let's graph that so we can see this visually. The b, which is the y-intercept, is at 3, so from the origin you go up 1, 2, 3. And the slope is negative 1, so that means I will fall 1 and run 1 right, fall 1, run 1 right, fall 1, run 1 right, or I can rise 1, run 1 left. And I'm trying to find the distance from that point to that line. And the thing about finding the distance is that it's going to have to be perpendicular to the line. So we have 3 steps to make this happen. I want to find how far it is from this point to this point, right here. And I'm going to do it algebraically. That's the length that I'm looking for. So the first thing is to find the equation of the perpendicular line. And we know perpendicular lines from the last video. You have to take the slope and flip it and negate it. So if the slope of the original equation, this one, is a negative 1 over 1, and I want the perpendicular slope, I'm going to flip it and change its sign, which is still going to be 1. It'll be positive 1. So I need to find a b now. To find the b, like in the last equation, y equals mx plus b, I'm going to take the y, and it's going to be this 1, 0, x, y. The y is going to be 0, the m's going to be 1, the x is going to be 1 plus b. 1 times 1 is 1, so 0 equals 1 plus b. To get the b alone, subtract 1, b equals negative 1. Okay, so the equation of the perpendicular line will be y equals 1x, we don't write 1's in front of x's, we just know that they're there, minus 1. Okay, so keep this in mind and this in mind. For step 2, if I set those equal to each other, I'm going to use the substitution rule to find out what the x and y is, where they intersect. And in algebra, you've already done it, but in geometry, this will be new to you. You will not have done this yet. So I'm going to take y equals negative x plus 3, and I'm taking the y equals x minus 1, and I'm going to take one of them and plug it into the other one using substitution. So it's written like this: x minus 1 equals negative x plus 3. And then I want to solve that. So I will add x to both sides. That would be getting rid of the smaller x, the invisible ones. And I have 2x minus 1 equals 3. That's 1 plus 1 is 2x minus 1 equals 3. Add 1 to both sides. So 2x equals 4. Divide by 2. X equals 2. Okay, so I've got one of my answers. I now need the y. It doesn't matter which problem I plug it into. I can use the bottom one. It looks a little easier. Y equals x minus 1, so that's going to be 2 minus 1. Y equals 1. Okay, so I have another ordered pair here. Ordered pairs, the x's are written before the y's, so I've got the ordered pair 2, 1. Now, to find the distance between these two right here, and so you can tell it was 2, 1, but I did it algebraically to make positive sure that it wasn't a fraction or something. We're going to use the distance formula now with the ordered pair 1, 0 that I had, and the ordered pair 2, 1. Here's the distance formula: the square root of x2 minus x1 squared plus y2 minus y1 squared, and here's my template. You can label them x1, y1, x2, y2, and that will help you put everything in the correct places. So the x's are 2 and 1 right here, and the y's are 1 and 0. So I have 2 minus 1, which is 1 squared, plus 1 minus 0, which is 1 squared. I have 1 squared is 1 times 1, which is 1, plus 1 times 1, which is 1, the square root of 2. Now, at this particular point, we're going to use a calculator to put in the square root of 2 and round that off to the nearest tenth, and that will be 1.4 approximately.